Hello everyone. Today, let's focus on the rational functions. From this question, we can learn how to sketch graphs of simple rational functions. To solve this question, we first need to factorize the function. Yes, so here we need to factorize. Let's set y equals to 1 over fx and equals to 1 over x plus 2 times x minus 1. Yes. After that, we need to consider the asymptotes of this graph. So the second part is determine the asymptotes. How we can find the asymptotes? Let's see this graph. Let's see this function. 1 over x plus 2 times x minus 1. We know that the denominator cannot be 0. So here cannot be the 0, which means the discontinuous. Here, x equals to minus 2 and x equals to 1. And we also know that the numerator is equal to 1, which means the y can't be 0. So here, the horizontal asymptotes y equals to 0. Okay. After we find out the asymptotes here, we need to consider the sum of points, like the point of intersection and the turning point. So the first, the intersection point, because the y cannot be 0, so we just only need to consider the x equals to 0. When x equals to 0, from the original function, we can know that y is equal to minus 1 over 2. So the intersection point here is 0 point minus 1 over 2. What about the turning points? The turning point here, we know that to find the turning point, we first need to differentiate the function. So which means the dy over dx needs to be 0. So let's write down the original function here. Y equals to 1 over x plus 2 times x minus 1. And I'd like to rewrite it as x squared plus x minus 2 to the power of minus 1. Okay. So dy over dx equals to minus x squared plus x minus 2 to the power of minus 2 times 2x plus 1. Okay. So minus 2x plus 1 over x squared plus x minus 2 to the power of 2 equals to 0. And because the numerator cannot be 0, so 2x plus 1 equals to 0. X equals to minus 1 over 2. So if we substitute if we substitute the x to the original function, then we can easily find the y is equals to minus 4 over 9. So here, the turning point we find out it's minus 1 over 2 points minus 4 over 9. Okay, so then we can draw the graph. I have already prepared for the graph. So here we find out the asymptotes. X equals to minus 2, x equals to 1, and y equals to 0. And also here is the 2 points. So let's consider the graph. the fourth part. So here, the x is near to the negative infinity. Denominator here will be the positive infinity, and which means the original function y will approach 0. It's positive. So here, the beginning point was shown like this. Then the x, if we consider x near to the minus 2, but it's smaller than the minus 2 here, the denominator here will be the 0, but it's positive. It's positive. So which means the original function y will approach to the positive infinity. So here we write at this. So this inverse proportional graph was shown like this. Now, this was shown as the inverse proportional function. Then let's consider if x is near to the minus 2, but it's larger than the minus 2. The denominator here will be the 0, but it's negative. So which means the y will approach the negative infinity. The start point will be there. Okay. So if x near to 1, but it's smaller than 1, the denominator here will shown as the will be the same, because if we near to the 1, the denominator will show the same pattern as the before. So here is 0 and negative. Y will near to the negative infinity here. And here is interesting. In this area, the line will also cross these 2 points. So we need to write down, draw this graph smoothly. Okay. So what about the right hand side? Well, the method is same as the left hand side. So it is still like a inverse proportional function. That's it. Good job. Thank you for listening.